Here we have the nucleus and the electron, both represented by clay models.
The valence shell determines the characteristics of an element because it is on the outside and it comes into contact with other elements first. Elements want to be stable. They do this by completing a full valence shell. The octet rule states that 8 electrons create a full outer shell. The only exception is hydrogen, which only needs 2. To create a full outer shell, elements can give, take, or share electrons. Metals, on the left side of the periodic table, give electrons, becoming positive cations. Nonmetals, on the right side of the periodic table, take electrons, becoming negative anions.
An ionic bond happens between a metal and a nonmetal. Ionic bonds become stable by giving and taking electrons. This happens because opposites attract.
Naming for binary ionic bonds is done by using the full name of the metal and the root of the nonmetal with the "-ide suffix.
Naming for multivalent ionic bonds is done by taking the name of the multivalent ion and the roots of the nonmetal with the "-ide suffix. Multivalent ions have multiple charges, so to find the charge, you take the charge of the nonmetal, so in this case, -2. Both sides need to be equal, so copper would have a charge of +2, represented by Roman numerals.
Naming for polyatomic ions is done by taking the name of the first element and then the common name of the polyatomic ion.
To write a binary formula, you take the element symbols and calculate the number of atoms to make both sides equal in charge, writing them as subscripts.
Remember, if there's 1, you write none. To write a multivalent formula, you take the element symbols and calculate the number of atoms using the Roman numerals as the multivalent charge.
To write a formula for a polyatomic bond, you write the symbols for the metal and the polyatomic ion and find their charge. So in this case, +3 and -2. Then you find their lowest common multiple to balance both sides. If there is a subscript on the polyatomic ion, then add brackets.
Covalent bonding is all about sharing.
Covalent bonding occurs between 2 or more nonmetals. They share electrons to get a full valence shell because they aren't strong enough to take electrons from another.
Covalent bonds are named using Greek prefixes such as mono, di, tetra, and octa.
To name the covalent bond CO2, take both of the elements' names and add the prefixes. Never use the mono prefix for the first element, but use the di prefix for the oxide. Now if it was carbon monoxide, you will have to eliminate the O in front of oxide.
The diatomic 7 are commonly found molecules with 2 same atoms including hydrogen, oxygen, fluorine, iodine, nitrogen, chlorine, and bromine, and are written with a 2 subscript.
To write the formula for covalent bonds, take the symbols and use the Greek prefixes to find the amount of atoms written as the subscripts. Now we're going to talk about the properties of ionic bonds and covalent bonds.
Ionic bonds have a higher melting point because they are held more tightly together by their positive and negative attraction, while covalent bonds are loosely packed and have a lower melting point.
Ionic bonds are soluble in water because H2O is a polar molecule. The positive end of the water molecule is attracted to the anions, while the negative end is attracted toward the cations. Now, the covalent bonds are not affected by this, so they are not soluble.
Ionic bonds conduct electricity because the cations attract electrons while anions push them. Covalent bonds have no charge, therefore electrons can't travel through them.